Welcome back to our session. Next speaker is Yuan. He will talk about Rust in ROS 2 and introduce about Hiroz. So let's welcome Yuan.
Okay, so hello everyone. So let me use Mandarin to introduce myself first. 我的名字叫袁佑元. My name is Yuan. So it's quite to memorize in Chinese. Yeah. Okay, and I'm solution architect working in data scale technology. I'm also the committers of open source ROS Zenoh, the middleware, one kind of middleware running in Rust 2. And I'm also the committer of the Zenoh protocol, which is also Rust written protocol. And today I would like to introduce you guys a new project that works just like Rust 2, but without the Rust 2 dependencies. You can use it in a very lightweight. So let's call it from Rust to Rust 2 and Hiroz. And in today's talk, there are only 3 keywords to memorize. The first one is Rust 2. I will try to introduce you what is the basic open robot operating systems. And then the Rust, why we choose Rust language. And yeah. And the third thing is Hiroz. So first question is, what exactly is robotics systems or autonomous vehicle running on a road? You can imagine that it's just matters of data flow. For example, you have several sensors like this, and then you have camera and LiDAR and some IMU sensors, and you will feed the data from sensor to some brain, like a perception module in the robots. And then you try to decide to interact with the real world environment, and then maybe you want to observe it. So it's all a matter of how data flows in the system and flow out to your dashboard. Okay, so that's a whole robot is. And talking about the mechanism of the data flow, there is one very popular framework. It's called publisher and subscriptions. It's not the classical end-to-end transmission, just like I know your address, I know my address, I send my data from my address to you. No. People just want to send the data easily by focusing on the data, the message format to send, and the network will automatically build up. That's something we would like to build. Okay, so we just declare the scan, like a /scan, that is the message data of the LiDAR could produce, and the recorder or the analyzers could fetch it, read it, something like this. We don't need to know who is the end users of this data. We don't. We just specify how data flow and what's the property of this topic. Like we said the QoS, we said the data should be reliable, we said the data should be transient local, so that the late joiner, the late subscriber joined to this network could recover those missing data. That's it. That's what we care, the data property of this message. Okay? And something bad happens because the current backbone of the Rust 2 by default is DDS. And DDS was designed for a stable network. Sorry. Yeah, for a stable network, but our world has already changed. Now we use Wi-Fi to do some remote control, and now we try to do some tele-opt on some microcontroller, and now we want to gather the data and publish, upload the data to the cloud so that we can do some training and then back forward backward to the robot itself. So now the network scenario has been changed to how could we make it extensible and how could we make it more resilient and more universal, okay? So that's why we introduced Zenoh protocol. The Zenoh protocol itself is zero network overhead protocol written in Rust. We try to abstract the classical pub, sub, and query. Let's satisfy what the robotics framework requires. I just demonstrate the data flow, right? And then we design the protocol to serve as the backbone of it. And please have a look at our project. It's open source. It's called Eclipse. It's under the Eclipse foundation. It's free to use. And in a nutshell, Zenoh itself is on top of the data link layer. We have the control of the data link so that we can interact with Bluetooth, serial link, or the network and the transport. So actually, Zenoh itself is quite extensible. Could be run on TCP, UDP, or with encryption like TLS, quick. Or even better, you can run in process, so we could use shared memory to have the best performance. And it's scalable, that we have many kind of combinations of routing that I will demonstrate later. And the performance one is quite good because we use ROS. We use ROS that we could have a fearless concurrency, and we could have more safety that used to explode in C++, but with a similar or better performance. Okay. So talking about the scalability, the first question is how could the network topology Zenoh support? So the leftmost one is DDS, is the classical peer-to-peer. So the network should be stable, and I assume you are already there and wait for my communication. That's it. But it doesn't. Obviously, it doesn't work on over Wi-Fi or over a net or talk to the cloud. Maybe it will be behind the firewall. So that is something we want to conquer. And in the middle one is another popular framework. It's called MQTT. It uses a broker to transmit the message between the clients. But the disadvantage of this one is a single point of tolerance, that failure. If the broker is down, then the whole system won't function anymore. So we try to design some decentralized systems, but also support 3 of them. The rightmost one is routed, that we make it able to cross some firewall, and we make it to do some cascade network. So for example, like this. The left-hand side, sorry, is too small, but I will try to explain it more. So the left-hand side is just the stable network peer-to-peer, but the right-hand side is we could set up some robot-specific network topology inside one robot, and also connected it to sites. So for example, you have many factory running multiple robots. You want to have a cascade level of control. And each level, we want to use some router to manage a region, to do the topic filtering, control the traffic flow, and also apply some access control, so that some critical data doesn't leak to the customer, something like this. So this is something we emphasize a lot in Zenoh protocol. We try to make it scalable, extensible, and still performant. That's it. Okay, and the second keyword is Rust2. So I would like to introduce you open source robot operating system. If you want to run some robots and you don't have any knowledge of the algorithm itself, I would suggest you use Rust because there are a bunch of algorithms already there, like the navigations or LiDAR perceptions or the planning module. And even better, the computer vision. There are lots of algorithms already there. And to dive into the Rust 2 this framework is actually a client library based on RCL layer and RMW layer. And RMW layer is abstraction of the middleware. Like Zenoh is one of the middleware, and DDS is one of the middleware. And you could use email to send your data. So there is also RMW mail middleware, or use file socket. All of them are possible. So in a technical viewpoint of Rust 2, it just do good abstractions and also embrace the open source contributor to join this community. We have algorithm layer and we do some abstractions. You could just satisfy this interface and run it. Okay, so this is the whole point of the Rust 2. And how do we use Zenoh following this scenario? Is you could easily swap the layer by changing the RMW implementation. There is an environmental variable, change it to RMW Zenoh CPP, then you could use it. It has been built in and officially tier 1 RMW middlewares. Yeah. And in today's talk, I also want to propose another solution that is Hiroz. Hiroz itself, I would like to make it compatible with RMW Zenoh so that it will be compatible with Rust 2 ecosystem. With more features I want. For example, I don't want to install Rust 2, which may contain some unnecessary package I need. So I want to have a lightweight versions of Rust 2. And furthermore, I want to customize and want to leverage the full power of Zenoh. For the left-hand side, the Zenoh versions, it used okay, let me directly jump to this one. The left-hand side is RMW Zenoh now we have. It on top of Zenoh Rust libraries and Zenoh C++ bindings, and then bridge to the RMW interface library. And the right-hand side, we want to provide, we could either make it compatible with RMW, or why not we just use the minimal stacks of Zenoh and just make it established as a runnable robotics framework. That's the whole point of Hiroz. Okay. So we could compare with other existing frameworks. The first one is Rust 2 Rust, which is one of the working group in Rust 2, that they try to follow the RCL layers and RMW layers, which are tons of unsafe CFFI, sorry. And then we write some unsafe Rust to bridge to this CFFI. It's also runnable in Rust 2, but it's not the native performance, and with many unsafety concerns. And in the middle one is Dora. Dora is also famous, which is data-oriented robotics. And for the network communication, they also use Zenoh as the backbone. But to make it bridge to Rust 2, they use a bridge, which sacrifices the performance. And the third one is our solutions. We propose, why not we just make everything run natively on top of Zenoh? So that's why we try to use Hiroz. Okay? And to answer the question about the language, like why we choose Rust as our priority, why not use C or C++, or why not use Go language? First of all, Zenoh itself, it used to write in a fancy functional programming language, or Camel. However, we found that it's, at the moment, it's really, the library itself is not so mature. So we moved to C or Go or Rust. Then let's debate. C itself is quite good to use, However, it's hard to debug. At that area, we don't have LLM. We need to debug it with our human eyes. It's a pain, you know. And for the Go language, it's quite easy to use. And however, the diversity, the design paradigms of Golang is quite limited because the philosophy of Golang, you want to make everything simple and stable. So, and there's also one concern about the performance. Golang is a GC language, and Discord once posted a detailed report about why they migrate from Golang to Rust language, because they observe a weird spike, the latency spike in their backlog, and finally they realized that it's because of the garbage collector. So our remaining choices are C++ or Rust. And at that moment, Rust is quite new and it's growing fast. So we almost going with the Rust development, and we used to use some native features in our products, and then it becomes stable, and then we merge it into our library. Yeah, and we feel very satisfied with Rust. It gives us the confidence of how safe a robotics framework could be, and how safe a Zenoh protocol could be. That's our story. And here's a glimpse of a different language. So the left one is RMW Zenoh CPP. We need to pass the unsafe pointer to a function, and in the middle one is RCO Rust. They use unsafe Rust to satisfy to fulfill the original request from the left-hand side, because the left-hand side was the unsafe pointer. And the right-hand side Hiroz itself is, there's no unsafe code at all. You just use it for free, and we could let the compiler to guarantee its safety. Yeah. And there is a quick demo about the API. Like we could use context and build out the context, and then build out the nodes associated to it, and then build out the publishers, which is quite easily with dot function code plus the type generic on it. Like we declare a Rust string and call the while let async receive. Am I highlighted? Anyways, we could use a streaming style, which is very modern language features in Rust. So we could stream the image, stream the LiDAR data in this way without using the callback. Okay. And the most important things of Hiroz emphasizes, we emphasize the interoperability. We make it compatible with RMW Zenoh. We make it compatible with the Rust tool. And we also want to embrace the user of different language. So we write the Hiroz library in native Rust, but we also provide a binding for different language. So here is an example that we could derive the message format, which is an abstract format, with Cogent, and then generate the C++1, Rust 1, and Python 1, and Go language 1. Yeah. Actually, this one is very difficult, because in Hiroz, we emphasize that we don't use any Rust packages to generate it. We don't use its IDL to generate the IDL. There is an intermediate data format. We don't. We just crack all of them in Hiroz itself. Okay. And we also extend the encodings, like we could easily extend the original CDR serializations to protobuf, because the front end, the website, they are more familiar with protobuf, and protobuf is I would say is much extensible than the CDR. So that is our whole pictures. We could use a router to bridge different language. We use it to discovery, and then they will talk peer-to-peer with the best performance. That is one of the features Zenoh can provide us. Okay, and regarding performance, we also do some optimizations on it. We provide shared memory so that we don't copy and resend the data, especially for large data like the image or LiDAR. And we also support in the POC that we could send the CUDA tensors directly. And for example, after a code generation of the message format, we can translate it to a data buffer that is native in Zenoh. And Zenoh itself is able to support shared memory or network I/O or CUDA tensor. That's it. And there is an overview of our comparisons. So this one, the third one is Hiroz. As you can see, it's better than the RCL CPP and the RCL PY. For just for your reference, we have a better performance. Yeah, this one, the third one. So we try to compare it under different scenarios: large payload size, small payload size, low frequency, high frequencies. Hiroz wins consistently. Okay. And the last thing is we also develop a platform. Actually, we support a tooling system. We call it Hiroz Union, that you can write your plugin and put it in the Hiroz backend. Like we have a demo in 2E versions that it can subscribe to the network and try to analyze it, which is quite cool. That we could directly use it without Rust install. Yeah. Okay, so finally, let me do a recap. I introduced you guys Hiroz and Eclipse Zenoh, the protocol it used, and the Amnet Zenoh already there in the Rust 2. All of them is open source, so please have a look at it. And I also want to acknowledge the OCF. They sponsor me to attend the FASTEM at the beginning of this year. FASTEM is the the biggest conference in Europe, and I try to introduce this robotics framework there. And people are very excited about the open source frameworks. So if you have chance, I would suggest you to attend this conference. FASTEM, yeah. So thank you all. The three takeaway for you guys is actually you can speak Rust 2 without running Rust 2, or even with more features and better performance. And what Rust guarantees could land on the layer of every message cross. If you want to know more details, I can introduce you, like how I use some techniques to guarantee that a mess across a Rust the test could catch the deadlock that used to happen in the C++ world. So I could leverage the Hiroz framework to fix some bugs in RMW Zenoh because it's written in C++ that the classical implementation in Rust 2. Yeah. Okay, so do I?
Yes, thank you so much. Thank you for our Yuan Youyuan. Giving you a big hand, yes. And luckily we have 3 minutes for the Q&A session, so any question we want to ask our speaker? Can you just raise your hand? Let me know. Okay, can you come to the stage? I will give you the microphone. Sorry, we have a bigger room, so you have to run a little bit.
Yeah, I'm really appreciate what you guys work. Yeah, seems you like you open a way for us to escape from C++. Everyone knows that C++ has like pointers, diagonal pointers. So my problem is how does a user of Hiroz takes the responsibility to re-implement the like data interface, like because in ROS ecosystem they have a text message, text format, text file to generate a lot of definition for the data format. So my question is, does user have to re-implement those things again on top of Hiroz or on top of Rust? Thank you.
Okay, so it's a good question. But let me clarify his questions. It's a good point. Actually, I have no sufficient time to introduce the tricks I use in Hiroz project. And so is this slide? We could use a single static format to generate the struct that could be used in Rust. Okay, and it's not simply this one. Just a second. Let me try like this. Jump to. You can click our docs. Here. It's a fancy website, so please have a look. I write it myself. And there is some core concept. No? Okay, so there is protobuf. Okay, here. So there is a message generation. I try to explain how I generated from the source code of type message definition, and it's quite extensible that you can have a look. And we have several ways to write down the message to make it support the serialization, like for protobuf or CDR to be compatible with Rust 2. You could either use my default toolchain or you write them manually. You could specify how to serialize each field. It's also possible. Okay. So you could have a look at a custom message. Like I try to plot several ways to interact, leverage the Hiroz serialization framework. So yeah, that's it. I believe you can find the answers here. Yeah.
Thank you for your question. Yeah. So Pete, we have a few time right now. So thank you for our speaker, Youyuan, again. And if you have any question, just ask him, talk to him later. And next session will be start at 2:45. So we'll come back later. Thank you so much.
Thank you all.